So, dear students, today we will discuss about reactions of benzene. In reactions of benzene, a typical characteristic reaction of benzene is electrophilic aromatic substituent. An electrophile, that is E positive ion, reacts with an aromatic ring and substitutes for one of the hydrogen over the benzene. Benzene does not undergo addition reaction because addition reaction yield a product that is not aromatic, and so as to retain its aromatic character, instead of addition reaction, benzene undergoes substitution reaction due to its resonance stabilization effect. This resonance stabilization effect of benzene is available due to the rotation of p orbital electron, that is pi electrons present over each carbon atom. So as to retain its aromaticity, benzene undergoes substitution reaction rather than addition reaction, even though it is a typical characteristic reaction of डबल बॉन्ड. डबल बॉन्डची आपण माहिती आहे टिपिकल कॅरेक्टरिस्टिक रिएक्शन कोणती असते इथे? Typical characteristic reaction of double bond is addition reaction. So this addition reaction is simply showing us the criteria for adding the substance into the double bond of benzene. Okay, but it is not possible in the case of benzene. अल्किन्स मध्ये आपण इझिली डबल बॉन्ड ब्रेक करून दोन सबस्टन्सेस तिथे ऍड करत असतो, पण बेन्झीन मध्ये आपल्याला डबल बॉन्ड जर ब्रेक केला तर याची एरोमॅटिक कॅरेक्टर्स जे आहे ते पूर्णतः संपुष्टात येत असतात. मग जर आता एरोमॅटिक कॅरेक्टर त्याचं संपलं तर हा एरोमॅटिक कंपाऊंड राहणार का इथे? नाही. मग सो एज टू रिटेन द एरोमॅटिक कॅरेक्टर इट हॅज टू बी part of substitution reaction rather than addition reaction. According to Huckel's rule, there must be the delocalization of pi electron in the planar ring structure, and there must be alternate single double bond. We have already seen that property. So according to the Huckel's rule here, these reactions of benzene are following the electrophilic substitution reaction with retaining its aromatic character in it. Now, the most important reactions of benzene are aromatic halogenation reaction, then sulphonation reaction, then aromatic nitration reaction, Friedel acylation, and Friedel alkylation. These are the 5 most important electrophilic aromatic substitution reaction that we have to study here. The first and most important thing related to electrophilic aromatic substitution reaction, it is being followed by the following step. In the step 1, there is a generation of electrophile. By attack of electrophile, there is a formation of uranium ions, that is positively charged species over the benzene ring. So these steps here will generate only the species which is associated with the compound of benzene. Whenever electrophile attacks over the benzene, this attack of electrophile will generate here the system or component of the particular electrophilic aromatic substitution reaction, and in the final step there is a loss of proton that leads to generate our desired product, a substituted product in the case of benzene. So electrophilic aromatic substitution, in which we require to generate first electrophile, then this attack of electrophile over the benzene ring for the formation of uranium ion, that is positive ion, that is electrophile, and finally the loss of proton will take place from the uranium ion so as to regenerate the aromatic character of the benzene. So once we regenerate the aromatic character of the benzene, it being considered as the final product here, and it retain its stability of aromatic characteristic. So now we will move towards the first and important reaction of electrophilic aromatic substitution. That reaction is aromatic halogenation reaction. In this aromatic halogenation reaction, we are using benzene and halogen like chlorine or bromine as a reactant. Then conditions, we have to use here a catalyst like FeCl3, which is comes under the Lewis acid category, and FeBr3. We can also use FeBr3 whenever we are using a bromine, or FeCl3 whenever we are using the Cl2. Okay, so analogous reaction with I2 and F2 means iodine and fluorine molecule are synthetically useful because not useful because I2 is too unreactive and fluorine is very vigorously react with the reaction. So violently it reacts with the benzene. So as we are unable to get the desired product, as violence will create there, it may create the explosion during the reaction mixture, and iodine is being reacting very slowly, so it is said to be unreactive. Why it is so? Because whenever iodine is interacting with the benzene substitution, here it generates the hydroiodic acid. As we all of us know that the byproduct of this substitution reaction is hydrogen halide. So in this case, the hydrogen iodide, once it is generated, it is acting as a stronger reducing agent which reverses the reaction. So this reversible reaction will take place. That's why the rate of reaction will minimize here, and it reacts very, very slowly. That's why it is said to be the unreactive towards the benzene molecule. So whenever we are carrying out the benzene reaction with the bromine water in absence of FeCl3 or FeBr3, if we are not using any Lewis acid or catalyst for this reaction, there is no decolorization observed in the reaction. So as no reaction observed here, no decolorization observed for the bromine water, then we say that there must be the retention of its aromatic character. But in the presence of Lewis acid like FeBr3 or FeCl3, this reaction is carried out over the benzene by substitution of bromine group instead of hydrogen over the benzene ring. So the byproduct is HBr, hydrogen bromide, in this reaction. We will take a look over the mechanism for the reaction of bromination of benzene. The first step is formation of electrophile Cl plus or Br plus. You might have heard about the ions which are formed over the reactions. Here in this case, the Cl plus, it is known as chloronium ion. आपण आतापर्यंत शिकत आलेलो आहे की क्लोरीन जो आहे हा क्लोराइड आयन, Cl मायनस आयन किंवा Br मायनस आयन खूप इझिली इथे फॉर्म करत असतो. बट दिस क्लोरीन इज ऑल्सो हॅव्हिंग वन ऑफ द इम्पॉर्टंट प्रॉपर्टी, क्लोरीन और ब्रोमीन having tendency to form the halonium ion, means a positively charged species. Whenever there is a heterolytic fission will taking place between the Br molecule in the presence of Lewis acid like FeBr3, it forms the FeBr4 minus salt and the Br positive ion as the bromonium ion. This bromonium ion in the second step attack over the benzene so as to generate the benzenonium ion, that is generating the positively charged species over the benzene, and this positively charged species over the benzene generates the aranium ion. It is a hybrid of three structures that are shown in the square bracket. You might have seen that whenever the substitution is taking place at any one position of over the benzene ring, the positive charge is always delocalized at ortho and para position with respect to the benzene, with respect to the bromine over the substitution. You might have seen here, look at here, here what will happen? This is substituting a benzene over the compound. So what will happen here? This substitution will create here a positive charge at the ortho position, at the para position, and again at the ortho position. So likewise we have the three positions at ortho, two ortho positions and one para position. So total three positions are there where the positive charge gets delocalized in the substitution of benzene. So this substitution of bromine over the benzene is taking place by the electrophilic aromatic substitution reaction by the generation of aranium ion by the substitution of bromine, and there is attachment of hydrogen over the cysteine. Here wherever the bromine is attached, at that point the hydrogen is already there. So still hydrogen is not removed from the reaction mixture. Later on it will get removed here. Okay, so in the next step what we have to see here, just to see, we will go for the next step. There is loss of proton from the uranium ion of the benzene ring. Now you can see here the bromine wherever it is going to attach, it is having the hydrogen in it. याच्यात काय आपल्याला हायड्रोजन पण आहे इथं, आणि हा हायड्रोजन जो आहे याचे बॉन्डिंग इलेक्ट्रॉन हा सरळ बेन्झीन रिंगला देतो आणि हायड्रोजन जो आहे हा इथे बाहेर पडून जातो. सो ड्यू टू दिस रिझन हिअर व्हॉट विल हॅपन, हायड्रोजन गेट्स रिमूव्ड ॲज अ H positive ion, and the H positive ion which is being removed as a loss of proton here, this H positive ion further react with the Br minus ion which is being abstracted by the FeBr3. So this H plus and Br minus will form the HBr. हे काय फॉर्म करणार इथं, हायड्रोजन ब्रोमाइड. अशा प्रकारे हायड्रोजन ब्रोमाइड हा इथे फॉर्म होत असतो ॲज अ बाय प्रॉडक्ट, अँड वी गेट अवर डिझायर्ड प्रॉडक्ट ॲज अ ब्रोमोबेन्झीन. हा काय भेटला आपल्याला, ब्रोमोबेन्झीन. So once we carry out this electrophilic aromatic substitution reaction, we get our desired product. Here the Lewis acid increases the polarity of hydrogen molecule. So as to increase this polarity, it produces the positively charged halogen ion, that is Cl plus or Br plus ion. So it is acting as an electrophile in the reaction. This electrophilic substitution will be initiated here by the attack of this positively charged electrophile. So similar kinds of reactions are possible in the case of phenols also. In the phenol also we are having the similar kinds of reactions. So you might have studied these reactions for your sessional exam. So you can say that here these phenols can also undergo the substitution at ortho and para position, because the positive charge is always generated at the ortho para position of the substituent group. That is a different kinds of reactions that we have to study the effect of substituent of OH group over the benzene. But in the case of benzene, it is having a plain electrophilic aromatic substitution reaction that is happening over the benzene structure. Okay, so this is the first reaction, that is electrophilic aromatic substitution reaction, so as to generate our desired product. Now next reaction is aromatic nitration reaction. So whenever we are carrying out aromatic nitration reaction, as I have asked one question to you people in the MCQ type, that which of the reactant is being used here for carrying out the nitration over the phenol. Most of you people has written the answer H2SO4. Now see here over the screen, you can see that the reactants required benzene and concentrated nitric acid, and H2SO4 is acting as a catalyst for the reaction which is being regenerated after the completion of reaction. So hence whenever we are writing answer to any question, read the question carefully whenever we are answering the multiple choice questions in your exam. So this is a general reaction where the benzene reacts with the concentrated nitric acid. In presence of concentrated sulfuric acid, this reaction is being initiated. In the step 1, there is a formation of hydrogen sulfonic acid, and this hydrogen sulfonic acid is acting as a receiver for the water molecule from the reaction mixture here, and this hydrogen, once it is being regenerated, it generates the nitronium ion from the nitric acid. So once it is being generated here, the positively charged species which is initiated from the sulfuric acid, it abstracts the proton here. So look at the step 1. For the formation of nitronium ion, NO2+, the sulfuric acid ionizes to produce a proton here. Once the proton is produced here, nitric acid accepts a proton from a stronger acid, sulfuric acid, and form of protonated nitric acid. This form of protonated nitric acid abstracts the proton here in the in this continuous state so as to generate the protonated nitric acid. The protonated nitric acid further dissociates into the formation of nitronium ion NO2 plus and water molecule. So the nitronium ion generated in the step 1, that is acting as an electrophile in this substitution reaction. In step 2, the attack of nitronium ion will take place over the benzene, and this attack of nitronium ion over the benzene will generate the formation of nitro group substituted uranium ion. So electrophilic substitution will take place, and again this structure is a hybrid of three structures as shown in the square bracket. Structure 1 having the substitution or formation of positive charge at the ortho position. The structure 2 is having at the para position, and structure 3 is having at the again ortho position. And in the last stage there is the loss of proton to reform the aromatic ring, and the proton which is liberated here from the reaction mixture, it is reacting with the HSO4 ion so as to generate our desired byproduct or H2SO4 as a reagent that we are using here as a catalyst. And we have the desired product of our reaction, nitrobenzene. So this is a general reaction that is going to be take place by the three-step reaction mechanism for the nitration of benzene. Okay, so this is one of the important reaction mechanism for our reaction. Now next reaction is Friedel-Crafts alkylation reaction. In the Friedel-Crafts alkylation reaction, benzene and alkyl halides are acting as the reactant while Lewis acid is acting as the catalyst. Here we use the aluminum chloride AlCl3 as the catalyst here for the reaction mixture. So the substitution will take place here by the alkyl group R gets substituted over the benzene so as to form the alkyl benzene derivative. This alkyl benzene, and there is a byproduct of HCl from the अल्काइल हॅलाइड मधला Cl ग्रुप आणि हायड्रोजन जो आहे बेन्झीन वरचा ऍज HCl म्हणून बाहेर पडतो, आणि इथे आपल्याला अल्काइल बेन्झीन ग्रुप हा इथे फॉर्म झालेला दिसून येत असतो. So this is Friedel-Crafts reaction. In this Friedel-Crafts reaction, we have example of methyl benzene, methyl chloride. Whenever it reacts with the benzene, it forms the toluene and HCl as a byproduct. Whenever it reacts with the tertiary butyl chloride, it forms the tertiary butyl benzene as a product and HCl as a byproduct. We will see the mechanism for this Friedel-Crafts alkylation reaction. In the Friedel-Crafts alkylation reaction, in the step 1, there is a formation of carbocation. Whenever there is a reaction of AlCl3 with the alkyl halide, it generates the carbocation, alkyl carbonium ion. अल्काइल कार्बोनियम आयन त्याला आपण म्हणतो किंवा कार्बोकॅटायन सुद्धा त्याला म्हटलं जाते. त्या कार्बोनियम आयन किंवा कार्बोकॅटायन जो जनरेट होत आहे अल्काइल ग्रुप वर, इट इज ऍक्टिंग एज अ इलेक्ट्रोफाइल which gets substituted over attack by the benzene ring here, and once it is attack over the benzene ring, it generates uranium ion over the benzene ring. This uranium ion again a hybrid of three structures as shown in the square bracket. This uranium ion further loses its proton to reform the aromatic ring, and it generates our desired product toluene, that is methyl benzene, and H positive ion is liberated. This H positive ion interact with the Cl negative ion so as to generate the HCl as the byproduct of this reaction. So this is another Friedel-Crafts reaction that we have to use here for carrying out the substitution over the benzene ring. Next reaction is Friedel-Crafts acylation reaction. In the Friedel-Crafts acylation reaction, reactant we use as a benzene and acid chloride. Instead of acid chloride, we can also use here acetic anhydride. In the presence of AlCl3, this reaction is carried out so as to generate the ketone as a byproduct, ketone as a main product. So this ketone, once it is generated here, this Friedel-Crafts acylation is carried out via three-step reaction mechanism so as to generate the ketonic product. In the step 1, there is a dissociation of chloride ion to form an acyl cation, acylium ion. Then step 2, that is resulting acylium ion or related adduct is subject to the nucleophilic attack by the arene group, and once it is attacking over the arene group, it is acting as a electrophilic substitution reaction. Once this acyl group, that is positively charged acyl ion, attack over the benzene ring, this positively charged acyl group is attacking over the benzene so as to generate here our desired product, that is chloride anions. So this chloride anion is finally generates the aranium ion, and we get our desired product, that is the final ketone benzene. आपण aromatic ketones तयार करू शकतो या रिएक्शनच्या सहाय्याने. So the step 3 is the formation of aromatic ketone. So this is the another reaction, and last reaction is aromatic sulfonation reaction. This aromatic sulfonation reaction in the organic reaction in which the hydrogen atom on arene is replaced by the sulfonic acid functional group, which is also an electrophilic aromatic substitution reaction. This concentrated sulfuric acid reflux for several hours so as to generate this sulfonic benzene groups, benzene sulfonic acid. The mechanism is simply the formation of sulfonic acid derivative here, which generates the sulfonium ion. The sulfonium ion attacks as the electrophile over the benzene so as to generate the aranium, and in the final step there is a loss of proton from the benzene aranium ion so as to generate the benzene sulfonic acid as our byproduct. So this is the overall review or revision of your electrophilic aromatic substitution reactions that is taking place or that are taking place in the benzene. So today we will stop here for carrying out the reactions.